All right, welcome. It's time to start. And today we're going to look at c3i files, header generation, and static dynamic libraries. This is kind of not very sexy, I think, in terms of what you like. There's not much fun to kind of look at most of the time. So I think that is why I've put it off for so long. So let's see if I can find some code that does something. So here it looks like I have created a dynamic library. Okay, so the problem is this. I might want to do a dynamic library. So I export this function, and which does nothing. Wait, let me just do the classic square thing, where you return things squared. And let me make a dynamic library for that one. Hopefully I picked the right one. So there we go. And this is going to end up in somewhere. Oh, it's just a test. Sorry. I have been testing this, so it has this test thing, which is bad. It doesn't give you an output if it completes. Okay. So now I created ABC test. Right. Let's see where that ended up. So somewhere here with my test files, with my resource files. Sorry. So resources somewhere in test fragments, and we have something like ABC test dilib. Yes, but we also get this one. So this is the one that has been generated for us as the extern, the header, right? And this ends up being a problem. So why is this a problem? First of all, well, in the most simple case, where you just have an extern function, there isn't a problem, right? It's just, this is fine, right? But as we want to do something more complicated, right, we might have, let's say it's a C long. Okay, so it's a C long. That's the way it is. Okay, so now I'm going to compile this, but this ABC test here, it will, okay, we'll go for this one and says, okay, that's an int 64. It's just that the problem is that's just on the particular target that we compile for. Okay. This could be some other target. Let's say we compile instead for Windows. Windows x64. Now let's do the same thing. Now we have an int 32. Because, sorry about that, I'm still having this, I'm still recovering from my kind of weird fever / illness. Now it's like the coughing. Okay. So this is a bit nasty, but okay, it's kind of sort of bearable. But there's another problem, because we also want to generate a c3i file for this. And in this case, what the c3i file should ideally just look like this. It should just look like basically this part here. This is the way it should look like. But to generate that, that's not trivial, because we can have all sorts of weird, if we expand this C long, we'll get something and so on. So do we expand or do we not expand? If we don't expand, then we need to pull in everything, all the definitions of C long and so on. And definitions of C long, let's actually C interrupt, right? So the definition of a C long is some macro getting the type, first getting the type ID, and then turning that into a type, and then defining the CU along as that. So this is not ideal, and it could be arbitrarily complex. So how do you take that arbitrarily complex data or source code and then turn it into a c3i file that works all the time? And that is a huge problem. I can add another problem. So let's add an import here. So we can import collections, list, like that. And then maybe we have another function that does something, but it's a macro instead. So this macro is going to take a number, and then it's going to create a list of ints, and then it's going to, for as long as, okay, this len, for as long as this is for everything from 0 to len, hopefully len is not so big, we're gonna push the I, and then we're gonna return it. So in this case, what do we need for this to even work? Well, we need to also include this c3i, should also import this part. But unless I read through the macro, I don't know that this is actually needed. So I would have to tentatively import these things, which I guess is possible. But my idea was this. So rather than generating the c3i file, you'd have to create one. So you'd create, let's see, I would create a new file, which I call debug libc3i. And that file then would be, right, so this thing, so module, my module, in here I would put the things like this one here, and I wouldn't need to write. Then we'd have some things like that. And I mean, I might have the macro, but the whole thing here, I would basically just hand this over, right? I wouldn't do anything about this. And then from this, I would generate the C files, the C headers. And I wouldn't, like, if it's just something in here that is export, I don't create a header for it. I just create headers for the c3i files. So that's the idea, and that allows you to also add good comments. I don't call this. and have all sorts of documentation in the c3i file, which will ship with your library, presumably. And then you'd have something like, okay, you have to dynamic lib, but you also have like, you have to have like export, and then you would have like this this file, which is what it's called, like the bug lib c3i, right? So you would say which ones you explicitly would say also which ones you would actually want to export. So that's what we were trying to do. So any questions here? So there are questions. So here, why did you make C3? How did you learn to make your own language? It's Ruddy Shoes who's asking. So why did I make C3? So originally I was working on contributing to a language called C2, which you can look at. It's at let me just put that right. Okay, so you can look at the language, which is at c2lang.org. So this should be correct. Just going to check that I sent you the right one. So that one would be correct, right? So okay, some weird stuff with the HTTPS. No, it didn't work. So let's see, HTTP. Okay, so you can't do the HTTPS. So just this one. That one will get you to the C2 language documentation. And so C2 is very close to C, but does change some syntax mainly. It actually, I think, removes macros now. Anyway, I was contributing that one, but at the time, it's back in 2018 or something. I felt that the community wasn't. Bas van den Berg, who was handling who was the author, and did all the accepting pull requests and so on. He was doing that all by himself, right? And I would wait for like 2 weeks for a pull request to be reviewed, because he was experiencing a burnout. Okay, so and then I was pretty much the only contributor, and all the previous group of contributors, they kind of faded away. I think when the development went down on C2 because Bass didn't have time, and then people left, and then I arrived, and then I felt that it was still Bass said that at the time that he was he was comfortable with it just being his hobby project and so on. And I thought it had a lot of potential, and I wanted to explore things, so I started to write the specs for a C3, adding a lot of features to C2. In the end, I actually started working on C3, and here we are. And now C2 is back doing development, so which is fun. I love that. But C2 is still, it's a little more. It's a smaller jump from C than C3. C3 is more. It's bigger. It's a bigger jump. For better and for worse, right? So anyway, so why didn't I go for like Zig or Odin? Might be a question, because those are the alternatives. Well, one thing is that I think familiarity of patterns and so on. That's important. I think that like keeping a familiar C syntax basically allows you to jump into the language more easily. So I thought there was a niche there for people who didn't want to abandon C syntax, who didn't hate C syntax and wanted to continue using C basically, but would like to have some additions. So that's why I started doing that. Okay, now that was long explanation, 5 minutes. And how did I learn to make my own language? Well, I contributed to C2, basically. That's how I learned how to work on a compiler. I also, follow stuff like what's called crafting interpreter. That was a great one. Just to go through, the lexer and the parser parts. Okay, let's see if there's something else. So, grandma cure, make tea with garlic, honey, and ginger. Yeah, it's not a normal cold also, so I don't know. It's anyway, I'm getting there. Okay, what's the difference between a c3i file and a regular c3l library? C3i is like just a C header. In a c3l library, you usually have a c3i file. So this like you can have constants, you can have declare variables, but you can't have. It's like a header file basically. Okay. Right. If there's not any more questions, I'll go ahead and start looking at this problem. So the question is where to kind of attack from what angle to attack this. So there are several things that have to be done in order to solve this. So there is how do you pick the c3i libraries files that are supposed to go into this, as opposed to c3i files that are part of a library or something, because the compiler will pick up all sorts of files. I think we can list all the files that actually does pick up. So let's see here. We have it somewhere. Print files, something files. So usually you would do not object output. Let's see here. Print input. So print input should be enough. Okay, so if we do print input here, hope you're not getting. I hear my kids in the other room and they're kind of loud. I hope no one is annoyed by that. Okay, so if I do something like this, we'll see the list of files that go into this, right? And we have the of course the one that's input, and then we have all the standard library files. And yes, all of those are like parsed and checked. But that doesn't take long. Okay, so given this, we can add our debuglib c3i, right? We could add that one. This is another file. Let's see here. Pull this up. and I don't know if you see this extra window. We probably don't see that. So if I do like this now, you should be able to see at the beginning we have the debug lib c3i. Okay, and it's just in there. We probably need some kind of, like, in order to have this actually work, we probably need to do some stuff up front. So this is exploration also. This is not just, this is kind of a design / exploration. Let's see how hard it is to do this. So I'm going to need something here that is by default. We're gonna set what the where can we place that? So somewhere up here. So we're gonna use standard library linker cc path. Maybe we add some part here which says printf export file. Export, so it should be a c3i file. So export c3i file as itself and as a header. Something like that. Okay, so we have to add that feature. So somewhere we could call it export. So we just need to find the match of E. Is there a case E? Just a large E. Okay, so case E. If match is a long opt, it's export, and so if options, it's gonna ignore everything else. So we need a so export needs a file, a c3i file, and let's, here are the linker libs. So maybe something like, okay, so export files max libders, export file count. Okay, it's not used, that's why I don't know what's underscore. Okay, so it's like export files, export file count. Oh, that was not it. So let's copy that one, and there we go. Let's see what we do with the linker lib, because we're going to do the same with okay, so we have here, so when we have a target, we're going to do the same thing. So just like we do with the linker libs, we're going to have a vec add, and now we don't have linker years. We have we're gonna add a list of export files, right? And those export files and we have to have file count. Okay, so now we have this list of export files. So let's see that, make sure that it actually works. So I'm going to add export and that c3i file, and let's see if, yeah, this is, yes, let's just see that it works. It doesn't, oh, it says there's an error. Can't process the unknown option export. They do something bad with that. So E, this looks like it should work. E, oh, I keep forgetting that. Can process unknown option. What? Mm. Oh, oh. Okay, so this one is just expecting the short version. So all the long opts are down here, of course. So now we're in the long opts thing, which is slow. This is like super slow because it just actually does it just matches everything one by one. But you don't have a lot of that, and you have the time. So okay, now that worked, and we didn't get this one as a, oh, let's see here. So we got export to debug lib and kind of brought that into everything. Right, so now we know that we have this export thing. And we should probably compile that one as well. So it's not just, it should be brought into the compile ones. So let's see what happens where you actually bring in the compile stuff. So let's see. We have the file somewhere, files, right? And then Japan files, and then you use those source tiers, and then the source tiers are get all those appended. But we're going to add that one at the end. So here are the build sources. And it's going to add those. Target expand. So if compiler build export files, and compiler, yeah, let's do that. Then we're gonna go for that and expand those export files. Export files. And it's going to, here's like a C3 suffix list, but it should really just be, you know, those files. And it goes into the object files. Does it? Should it? Okay, let's just do it like this. Okay. So export files. This is like a to do make this leaner. And let's make sure that it actually is pulled into the files that are compiled. Yes, it is compiled there. Let me see if you have some question. So we can't see the command console, only the editor window. Command console. Well, like, okay, so I'm not, when I open stuff, it's the, maybe I can change this. I don't want to do this right now. I get a pop-up where I kind of change this part, like the compile dynamic single, blah, 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 which is like editing this, basically. So it's not doing anything funny. So I'm not actually entering any terminal commands as such. I just update the this part, really, that sense, this part. So nothing special. Is that okay? I think Tonios 2. Is that okay? Maybe there's an answer or not. I'll look at that later. At least you see like the output and everything, right? You can see the output at the bottom, like the files and so on, right here. Is this clear to everyone? Right. Good. So that's all we need to really see. Okay, so now we have everything compiled, everything is fine. So now we're going to build the headers, and that's a part of the. We're going to do different things too, but in order to do this, we can start by making the headers nicer. So here's something creating headers. I hate this file like this because it's like, so you just have to do this so messily. Okay, so this is actually cool somewhere. So header gen, I think there's yeah, here it is. So the header gen will create the header for a particular module, and that's the way it's supposed to work. But we're gonna rip that out. So if we have build output headers, then we're gonna header gen not those, but we're gonna header gen on the files. So the c3i files. So we're gonna do like for each I guess file. It's going to be like in a module. You're gonna have. So here's the thing: with a c3i file, a c3i file could contain multiple modules. I can have, will probably have multiple modules. So it can be like bar, right? So this is completely okay. What you have is that each module has multiple compilation units in it, one or multiple. So if you have a module in two places, then those might be the same of compilation. So the same file or not. So I can, if I do something like this and do something else here, right? Then this is one compilation unit and this is another. This is the same module, but they are treated differently, kind of differently. So what I need to do now really is a bit complicated. So I need to go through the modules. So let's see what this one does. So this one tries to kind of zero it and run it for these modules. But we're going to say, okay, we want a particular, we're going to do this for each compiler build export files, right? So that's a const char oops, file. This is a macro for iterating over things. And let me think about that one. That one have a... Yeah, you did your own stuff, right? Or... Okay, sorry. So, like that. So now we're going to do header gen, but we're also going to pass in the file. So we're going to create one header, and then we're going to look through all the modules and see if we have something related to that. So I'm going to up this one to take a constructor file name. Just do something like that because I want to see where that breaks things. Okay. So find usages. It's just here. So it's just going to be like the file, modules, and module count. And now it was up with the file name. Let's just call that c3i file name, right? And then we're going to generate a table just like before, but the name here is going to be like string remove suffix. Now we're going to like do something really brittle, right? This remove suffix is so we're going to remove the suffix, which is c3i. So it's going to be like, does it allocate anything? Yes, it does. So the name is actually this. So we're going to remove this part. Okay, and then we're going to get the name. Now we have file name.h. Now we can start having fun. So we're going to go through the compilation units. But if it's a unit, so the unit itself is going to be like have a file. And if the file name equals the c3i file name, if it doesn't, then continue. Right, and let's see if we ever get past that. So I'm just going to see if this works, kind of. Oh yeah, we do get something. So let's see what happens. So we got an MBC test. So let's see, ABC test. So we got my module foo2. Is that one is that one in here? No. So it's okay. No. Sorry. The name is now not ABC test. It's going to be like this debug lib. Here we go. And it has foo2. So that one is not in here, right? Yeah, of course it is. Okay, no, I'm being stupid here. So why is the foo2 in there? So because we exported this one, right, from this module, but we didn't. I think we didn't make sure that we just excluded that one. So okay, let me just jump in here and see what happens. So we're in the compilation. Like now, I'm actually really using the compiler. Wait, hey. Okay, where did we? Let's. Can't I set it? Yes, right. So okay, we get in here. So now we're in. We're in the. Let's see if we can get. So the unit. There you have the unit. And the unit file is the full path as something like test fragments and c3i. So this is fine. So now we're going to go through the declarations in here. So we don't have any type declarations. Okay, that makes sense. So then we'll process the queue. Oh, but we didn't do this right. So we're gonna go through these, and then for the types we would have done the right thing. But then we also have this one, and we didn't skip here. So we want to skip this as well. So maybe no, we can do this. So again, we're gonna have like a file name. We can c3i file name here. So this one is called somewhere. Here we go. So we do this. Okay, what do we get now? We have to, by the way, we have to have a foo. So this one is a foo, and then we have another foo. Like that. Okay, we have two foos now. Because we did indeed declare it here, and then we didn't use it, so we're going to need to clean up something up here. So maybe, so this is a problem. All the other code will assume, I mean, if you have something in two places, right? So then this is bad. I can remove the export here. Perhaps. So what we want to do is like make this work. So the c3i file suddenly becomes something else, and that's tricky, to be honest. That's tricky. It's like it now has two meanings, and it's not ideal, because c3i file usually. A c3i file will say, okay, this thing is declared somewhere else. I know it is, it is declared somewhere else. But the code is not really into that shit. It doesn't really know. It isn't really happy about that. Oh hell. The complications of these things. So the way a c3i file usually would work is not how it works now. So maybe I don't know. There are, I guess, like you could read the c3i file, and then you know the fact that it's in there and it's not defined, but will be defined somewhere by the library, is given kind of a weak definition. But then we want to know that it's in this c3i file, because we want to we want to create this definition as a header file. And we also want to add export to it. So okay, can we do that? So this previous use of foo was here, and that was when we were looking at what the debug lib. Okay, so it was shadow something, right? Yeah. So what we're going to do is we're going to add a bit of functionality. So foo would shadow a previous declaration. I'm gonna jump to this here. And now we would need to do something about that. So if we want to add, this is just for the globals, by the way. And it happens in like the it is a bit gnarly. So let's see, the error is just there, right? So there are two places where it could be. It could be in local symbols in which case it's an error, right? It could be less than local, in which case it would not be an error, but we have this case, right? So we try to set it, and we have an old one. And so we're gonna say that the old one would shadow a previous declaration. Okay, so right, sorry about that. So the old unit, the file, is it a, if the new one, so which one should we keep, right? If the old one, let's always go to, we're gonna go to the area anyway. We're just gonna have fun, maybe. So the unit itself, can I see if that's an interface file or not? I think I can. If it's an interface file, so if if unit is interface file, so if unit is an interface file, in this case we want to take the declaration. So the old is null declaration. So the old is then going to be set again. So I'm going to reset it with old. I'm going to keep that one, but you're also going to set this one to is export equals true, and export it. And then we'll have to actually, at this point, we can't compare them. So we need to do something later here to do. Okay, but there's another, so this is one case. And then we're just done. So this is fine. And the other case is where the declaration has a unit, which is an interface file. And sorry, so the old is an interface file. So if this is true, then the declaration is export equals true. And we're done. Otherwise, it's an error. Now the shit's gonna have to hit the fan about this. But these are they become hidden at this point, right? So they kind of become hidden. But if something else, I mean, this can happen at any time. And so anyone who's been, using the interface file symbol will now have connected to the wrong symbol. So we need to have an alias. So in this case, right, the declaration should be like a type def, and the type def declaration is redef. What's that? Okay, it's when it has a different name. Okay, so this is kind of correct. So like this. And in this case, it's old is going to be like a type def in a very wide meaning here. So the type def decal is going to be like decal, and this is not going to work. But let's see when this works. Okay. So there is this define decal, is that said? And it's going to be doing what when you copy it? The copying is actually very revealing. So here's the alias, and whenever you get something like that, you can get the alias, and it has a symbol, blah blah. And we could probably leverage this if we like say that the definition is already. If we say that this resolve is done, then we can take the define decal alias and set that to decal, right? So this should be fine, and then we do it similar here. This is really just hacking at this point, and then I have to clean it up and like say that this is actually the way to do it. So in this case, we kind of create these aliases, right? What happens if I do that? Like, oh, oops, it actually does work. That was unexpected. Okay, let's see. I mean, I could just, the main here should be calling foo 1 2 3, right? So does this work? Does it, so what would you miss? Like you have to check that they actually match, right? Because it could be something else. So it could be like this, right? So nothing is preventing you from doing this, and it's just going to say, okay, that's fine. You know, here's like, yeah, fine. So that's not great. So we're going to look at what we got. So the bug lib, how does it look like now, right? So now we're getting foo 2 and we're getting foo. Do we have foo 2 here? No, why do we get to foo 2? Let's just make sure that this is generated now. Yeah, it is. Okay, so I get foo 2 and foo. Okay. So I get foo 2. Why? Maybe because it's exported or something. And then I get foo. And foo is not exported here. This is something generated because we get this thing in here. So if I remove foo from here, we shouldn't get any foo anymore. And yeah, it goes away. But we shouldn't get foo 2 either. I think that's weird. So we're going to look at why we get that. So we're going to do the header gens, and we're going to go through the c3i, and then we'll end up here at some point in time. So we can probably see what it looks like. So it's empty, right? So far it's empty. And then we're going to go like one step at a time. And now after processing the queue, it looks like still empty. And then we're going to go through this last thing here, and we're going to go in here. Right, so through the modules, okay, no modules. Finally, we might have something, I guess. I don't think we do because these are constants, right? So finally, we get the var decals, so vars. I don't think we get anything there either. And finally, it's the functions, right? So let's see. Okay, we didn't skip in the function case, so that's why we got everything. So again, we're gonna skip unless it's one of those, the one we like, right? And again here. So okay, let's see what we got. Yeah, I'm going to continue just to 1 hour. So let's keep it short for now. This will take a while to actually. Okay, we didn't get anything now. That is very sad. I did have the foo now. So why didn't I get one? If I put export here, then is it happy then? No. Okay, maybe I was too aggressive, I guess. Okay. All right. So let's see. We go into here. At some point, we're going to go into the functions, right? So we're here now. Do we have any functions? Womb. Yeah, it actually has function. So if it's not an export on the decal, then it returns, right? So in this case, we're gonna assume, wanna assume that this is in an interface already. So then we can always export it, right? So we can always do this. We don't have to do this check anymore, right? Why should we do that? No need for it. Oh, there's what? Oh, so there's the type. Wait, hang on. It's a function, right? So you're gonna get to the function, and the function is foo, but it's a define, right? So we're gonna go and we're gonna have to decal flatten. Yeah. So we're gonna take the declaration and we're going to flatten it. Flattening means that basically you walk through an alias. So okay, we're not going to do any shadowing space. So now let's see if it works. Yeah, okay. Here it is. Our dear my module foo. I feel so proud. Okay, so that worked. That was a function, right? So what if we have a type? So we have a struct type which is foo for some reason, and of course this is by default an export. Oh wait, hang on. Let's move that export. Right. All right. So still in there. Good. Everything is fine. So next step is we want to do a struct foo, and it's gonna be like this. It's gonna be fine to have structs that are not in anything else but the interface file. I think that's going to be okay. So let's see here. We don't have any types at all, right? I think if we put an export on this, it would work. Perhaps. Let's see. Now it works. Right. That means that we have some problem. We are looking at if there is an export on in the header file. So let's see, where's the struct. So here's where you print the types. And if it's an in something, but we only print the types. So let's gen and num, gen members, print type, gen maybe generate type, maybe there. Or print type. Okay, basically I have to go back. So let's go to header gen. Everything is usually prefixing stuff is great, but here in this one it's just like it wasn't a great thing. So okay, so let's look at that. If not type is export, continue. So again, we're gonna assume that like if okay, so first of all we're gonna skip everything that's not if not an interface file, or it's not our interface file, and then we always agree we can always skip that because it's always going to be fine. So now we have it. So it's our foo bar here. We're just going to do type def. It's always do just type defs, and those names are so ugly. That's the way it is for now, anyway. Okay, so sorry about that. Okay, so it's just kind of +5 now, but the direction here is going to the next step would be to continue doing this, make sure that the other things work, and now of course we didn't test this, and we will need to test this, which is we're going to do like a struct foo bar here, and now things are going to break because boom here, because we didn't do the flattening. So we always have to do like maybe generate type. Okay, so in this case, we get something gen this. Then we have to do decal equals decal flatten decal, right? And there's a danger here. So where the question is like, is this correct? The decal flatten isn't for types, especially. It's not really used extensively, so things can get wrong here. So maybe it should be handled differently, just to avoid these issues. But for now, this works, right? And I'll just put this in on a shelf. So I'm going to shelf changes and going to say like working on c3i based header export. So it's not necessarily so that I'll continue with this solution. So this work, like a 1 hour, gave me an idea of like what's the trajectory of this kind of solution, and and also what kind of issues I would run into. So the tricky part here is actually the overlap of these multiple declarations. So you have the declaration in the c3i file, which is going to be exported, and you have the actual implementation. And you will have to be very careful about how that works. And they need to match up. There's like one thing, we didn't try to do that at all now, but they need to match up, and they need to also kind of work together. It's nothing else should be used in the interface definitions. Everything should use normal code definition. So how do I make sure that that actually happens? And what about these helper types that I said could be added here? And how do we check that these actual functions in the exports are actually defined? Those are things that you have to clean up. Let me see if anyone has any questions. Right. Are you the creator of C3? Yes. Well, so any questions? So otherwise I'll end it here. I give you a few more seconds to think about it while I'll kind of think about the implications of doing the aliasing. It's a clever solution, but it's not very clean. You could on with C++ or something, you could hide it, but you can't hide it really in C. You would have to do the flattening everywhere, which should be done, but and for types you usually do an alias. So again, it feels somewhat unclean to kind of handle it in this way. You'd have to. C3is are special. So you could also kind of, after compiling everything, that's when you run the c3i file on everything that's already completed, and then you just compile it in the same way as usual. So the c3i file could not be affecting anything else. And then you'd have to make sure that everything was, all the definitions were defined. Um, and also then in that case, all these like these aliases that you make will be something that you could check afterwards. So you could go through these files, these compilation units, and make sure that everything is aliases. And then and those would update the kind of export or not export for the particular functions. I wonder though. The other way would be like to always run the c3i files first, make sure that all these aliases are placed differently. They could be handled completely differently. Okay, yeah, I'll give that a thought. So, what is your recommendation if I want to add a new feature to the language? What are the steps to get into the compiler code? Yes, it depends. Like, do you want to fork the language itself? Or do you want to add some feature that is already agreed upon, right? That's like the different, quite different things. When you look at the compiler, it does it consists of the lexer, right, and the parser, and semantic checker, and the final step is the LVM codegen, basically. And now I see, like, listening from my family here, and they're making sounds. Sorry about that. And you can, if you want to add something, to the front end, then you, like, if you look at the compiler, we start, basically everything starts with running the compiler, like these files here, and then, or actually the build, which is outside of that. So the build, loading the build stuff, or stuff from the project, the project JSON, and then you go into the compiler, which is here, and that one will launch the parser. So, and the parser will just go through and create an AST, and then that AST, and the parser will use Lexer to do so, right? So if you want to add a new, let's say you wanted to add match, right? Then you'd go into the tokenizer, and basically you would add a token called match somewhere, and you would basically you'd follow where's it, like for each in this case. So turns out the for each is just in these places, right? You have a definition here, and you have one when you parse the for each, and you have another one. Yeah, this is detecting parsing, and then this is actually one that creates the token so that you know what the token looks like, right? So it's for each. So it's very, very simple to kind of create those. And then you go into the parser. The parser, works from the top in a normal way, like parsers in general do. There's like they start parsing the translation unit, and then they start like parsing the top level statements. And the top level statements may be different things, like the function, and you start parsing the function definition, and then you go like recursively down. So you parse the function definition, and then you would parse the body, and the body would say like you parse the body by statements, and the statements contain expressions. So if you do something and you want to add a feature, you probably want to parse it, and then you need to automatically check that thing. So for example, let's say you have added a new statement. Here's the declare statement. This is how you check it. So you check it. Oh, maybe the other one's bad example. Here's a try unravels. That one is pretty complicated, to be honest. Let's see something else that's like normal. So here's a continue statement. So first you check that it's possible to have continue there. You update some data. If it has a label, it does look up the label, and then you're going to set what some defer stuff on this. And now we set it up, and then we're done. Then finally, the last part is doing the code gen for this thing. So then you go into the LLVM code gen, and then you go to the statement, and then in whatever thing you have, like emit continue. Right. In this case, you're gonna emit a branch, a jump to whatever target you already defined for that. But yeah, they are defined fairly apart. So you need to, if you are doing something that is in the part before you compile, then it's like in the compiler C and build and so on, that part. If you go deeper and want to add like a statement or an expression, you need to understand how you parse things, and then semantically check those, and then finally how you generate those. So they are in 3 places. Everything will be in 3 places. But the simplest way to kind of see that is like, for example, let's say you have an if statement, right? This is a simple enum token, enum here. So if I just look at the usages here, and I'm going to use c3i here. So if you go through here, these are the places where you actually handle them. So there's a copy, because the macros need to copy all the code. There's one place where this kind of plays in a break and in continue, obviously, and then emitting itself. And then we have when they parse it, and then apparently in some way in a macro we have something, and it's probably related to the first and so on. And then we want to do liveness tracing. So we trace the if statements to see what kind of declarations are in use, because those are live and those are the ones who are going to end up in the final binary to make it smaller. And here's the analysis of the if statement, and this is the one that makes it jump to that. So this is like telling me that, this is like the places where if statement handling starts and how it works. So this is all you need to know if you have something if, like, for example. And if you see that, you can copy these parts and then you just modify it the way you want. Fernando, is that helpful? Hopefully it was. Okay, so any other questions? Thank you. Yeah, good. All right, then I'm going to stop recording here, stop streaming here, and wish you a very pleasant evening. It's now 20 past 5 here in the evening. So have a great day, everyone, and goodbye.